In this video, we'll discuss loans and amortization. Now, amortization is the process of repaying a loan. Because you are paying at the end of each period, the process of using amortization is actually the same as the present value of an ordinary annuity, which we've discussed before. It's just taking that same concept and applying it to loans. So that means that we will have periodic payments that are always equal. And that's going to include both the interest and the principal of the loan. And because it's including both the principal and the interest, which are often being compounded, early payments are mostly interest, and late payments in the whole amortization process are mostly principal. And you might be asking yourself, well, why would that be the case? And it comes down to the idea of compounding. So here is the first 6 months of a 30-year loan on $195,000 that has monthly payments of $959.29. And we can see here in the first month that $268.67 are paid to the principal, and the rest is interest. Now when we go to the next month and it's being compounded, we remove this principal from the total loan. So there's no longer $195,000. There's now $194,731.34. And what that means is that there's less principal to actually charge interest. And so from payment to payment, more and more principal disappears from the total loan, which means there's less there for there to be interest. Thus, more of the monthly payment goes towards the principal. So because of this, we can actually use the same formula as the present value for an ordinary annuity. What we have to pay attention to is what each of these components mean. When we look at the A value, that will be our starting loan amount. That's the amount that you start by saying, I'm going to borrow this from the bank or borrow this from the company. P is going to represent that periodic payment, whether that's monthly, quarterly, semi-annually. That's the payment that's going to be made for the term of the loan. R is still our interest rate, written as a decimal. T is still time, written in years. And N is still the number of compounds, how many times interest is being computed in a year. Again, most common ones are quarterly, monthly, and semi-annually. So let's look at an example here. Say that Tanya wants to buy a car that is $32,000. She can get a 60-month loan at 1.9% annual interest. What will her monthly payment be? And we're going to round that to the nearest cent. So first, we recognize that the amount that she's starting with her borrowing is $32,000. And they're asking, what's the monthly payment going to be? That's what's unknown in this case. We know that it is going to be 1.9% or 19 thousandths. We know that the loan goes for 60 months, but remember, we write this in years, so that's 5 years. And then we know also that's compounding on a monthly, the payments are being made monthly, so that's 12 times a year. So we have our information and we substitute into the formula. Here, we're going to be solving for P. And since we're solving for P, we're going to simplify everything inside the parentheses and then divide both sides by that value. So I start by simplifying where my division is occurring, as well as simplifying my exponent. So you can see I have a lot of decimal places written here. Again, I want to carry as many as I can get from my calculator from one step to the next to make sure my answer is as accurate as possible. So next, I would now raise my value to the -60th, subtract that from 1, and now I can divide my numerator by my denominator. Now I have this number 57 and 19, and keep going on with all your decimals, times P. I can divide both sides by this value and then realize that that's the monthly payment. And monthly payment goes to the cent, which is the hundredths place. So Tanya will have a monthly payment of $559.49. Now, here's another example. Say instead Derek's trying to determine how much he can take out for a loan. He'd like quarterly payments to be made of $900 for 4 years on the loan. If a bank has a loan option with 5.6% annual interest that compounds quarterly, how much can Derek borrow and stay within his budget? So here we're asking how much can be borrowed. That's our starting unknown. The payments Derek would like to make is $900. He wants to do this at a 5.6% annual interest rate, and that's going on for 4 years. Then we can see that he wants to make quarterly payments, so that's 4 times a year. So in this case, we're solving for A, that initial loan amount. So we're going to simplify everything on the right-hand side. Again, we start inside our parentheses. So we start with our division, then we can raise 1 14 thousandths to the negative 16th, subtract that from 1, and then divide by the 14 thousandths in the denominator, and now multiply that value by 900. And again, look how many decimal places I'm carrying, because I'm trying to keep the answer as accurate as possible from one step to the next. It's not until I get to the end that I'm rounding. And here I can say that I'm rounding to the nearest cent again. So Derek can borrow up to $12,821.28. Now, the actual cost of a loan is actually much more than what was borrowed. And that is because you have to take into consideration that you're borrowing with interest. So the actual cost will always be the monthly or periodic payment times how many times it's being done in a year times time. Now the interest paid is that actual cost minus what did you actually borrow. That tells us how much was paid in interest. And it's good to know those two things to figure out what's really happening when you borrow. So let's go back to Derek. Say that he borrowed that full $12,821.28 to remodel his kitchen, and he made quarterly payments of the $900 for 4 years on the loan. We know how much did Derek pay the bank by the end of the loan, and how much was the interest on that loan. So this is what he started with at the bank, the initial loan amount. He's still making those $900 payments, doing that for 4 years, and doing it quarterly, 4 times a year. So the actual cost is that payment times the number of times in a year times how many years. 900 times 4 means that he paid out in the end $14,400 for the entire loan. So to determine then, well, what was the interest? It's taking that actual cost and subtracting the initial loan amount. In this case, we already found the actual cost to be $14,400. We're just going to subtract the loan amount, the $12,821.28. So that in this case, Derek paid $1,578.72 in interest for his loan. Now, one last thing that can come up with loans is the idea of a remaining balance. And it's good to understand how to calculate a remaining balance because often this can be used to pay off loans early. And this happens many times for people. Maybe they get to a certain point in the loan, they're like, oh, I have the extra funds. Let me pay this off and be done with this loan. And it's calculated slightly differently because you have to remember that when the loan is given, the expectation of interest is still there within the loan for the duration of the loan. So the loan, that present value formula changes just a little bit. Our A now represents the remaining balance on the loan. And our T, we have to look at two values for time. What was the entire duration of the loan? And we're going to subtract actually how far into the loan we've gone. The rest of it will be the same. Now let's look at an example where Leslie took out a loan for $25,000 to purchase a car. The terms of the loan required Leslie to make a monthly payment of $386.59 for 72 months at 3.6% interest compounded monthly. After 48 months, Leslie wants to pay off the remaining balance. How much will Leslie have to pay for the car company to complete the loan at the time? So here, we're trying to figure out how much is left to pay. What's the remaining balance? That's what's unknown. We know Leslie's making a monthly payment of $386.59. We know that that's at 3.6% interest, which is 36 thousandths. We know that that's the full length is 72 months, which is 6 years, whereas the partial length, that where we are currently for Leslie, is 48 months, which is 4 years. And lastly, we know these are monthly payments, which happens every month, so that's 12 times a year. So we take and substitute in our values here, and the difference again is what we're doing with our time. Here we're condensing the time that's left. So we're going to simplify our division and our exponent. So this becomes 1 3/1000 raised to the negative 24th divided by 3/1000. So I'm going to take my exponent here, subtract this value from 1, and then divide by 3/1000, and then multiply the value by $386.59. And again, I've kept all the decimals I can up to this point. And now I can actually round my value so that I can say that in this case, Leslie will need to pay the car company $8,939.10 at the end of 48 months to complete the loan repayment.